Hello everyone, welcome to the lecture series Computer Organization and Advanced Microprocessors. This is our 13th lecture, and in this lecture we will learn about the integrated circuits, and in short we call it IC. You must have heard this term IC, and we will learn about this IC in detail in this lecture. So let's start. Okay, so now let's first see the difference between the discrete circuit and integrated circuit before we start with the IC in detail. And even before that, let's understand the circuit, the term circuit. So normally in electronics, a circuit is a closed path. We call it a closed path that allows electricity to flow from one point to the another, right? You all of you have must seen the circuit, and what happens when we apply the power current, it starts that device, right? So it may include various electrical components. This circuit may include various electrical components like transistors, resistors, and capacitors, but the flow is unimpeded, we can say, by a gap or a break in the circuit. If we talk about the example, then flashlight is the best example of the simple basic circuit which has some components. We apply the power supply and it gets started, right? So here we have two different circuits, discrete circuit and integrated circuit. So what happens, discrete components, let's understand the term discrete. Discrete components means a component with just one circuit element, right? Discrete component means what? Discrete means a component with just one circuit element, either a passive means what type of, like resistors, capacitors, inductors, all are a passive element, we can say. And active means a transistors or a vacuum tube, like that. So whereas integrated circuit means a thin chip, you can see in the image. IC or integrated circuit is nothing but a thin chip, and usually of silicon, consisting of at least of two interconnected semiconductor devices, and mainly it contains transistors only. So this is the basic idea of the circuit, and two types of circuits, one is a discrete circuit and another is an integrated circuit, and we'll learn about the integrated circuit in detail in the following slides. Okay, now let's start with the discrete circuits first. First we'll see about the discrete circuit and then we'll learn about the IC in detail. So in DC, components are manufactured separately. You can see that on this discrete circuit you can find many components, right? And all the components are manufactured separately, and after that we assemble all the components on one board. And how to connect all these components? So we can connect all these components using a conducting wires and breadboard or a PCB. So PCB, all of you have seen that what is PCB. So what is this breadboard, right? So breadboard is nothing but a rectangular plastic board. You can find on a Google that breadboard is nothing but a rectangular plastic board with a bunch of tiny holes you can find in it, and these holes let you easily insert electronic components just to make a prototype. We cannot make a final circuit, but you can make a prototype, like a meaning a build and test an early version of it, because of course when you are designing, when you are manufacturing any PCB, before that you need a prototype to test all the components, and for that we can use a breadboard, right? Okay, so these components can be resistors, diodes, transistors, and inductors. We are not going in the detail of these terms because this is a physics electronics part, but if you want to search, if you want to read about this, you can Google it. Then components are combined to perform a particular output. Of course, when you assemble all the components, definitely they are going to perform one specific operation. So in such a manner we have to combine them, connect them. For example, we can use a transistors to create a logic gates. Okay, if we now we know, right, what is logic gate. So suppose you want to design a NOR gate or a OR gate, you can use transistors, and using the transistors and some wires you can design the logic gate. So discrete circuits can be designed to use in a low voltage or a high voltage. It depends on the accessibility and the compatibility of the components. Depends on the circuit, depends on the device type, that you can build it on a low voltage, also for the high voltage. Just like we know, low voltage means a 0 and high voltage means 1, right? Okay, so it depends on accessibility, that what type of this device you are designing. And yes, you can find most of electronic device are a mixture of discrete components and ICs, as we have already discussed in our last live session, that you can find mixture of this both the circuits in almost all the electronic devices. So it's just an idea about the discrete circuit, basic idea about it, and more we'll learn about the IC in detail in next slides. Okay, now let's start with the integrated circuits in detail. Basically, IC is also called as a microelectronic circuit. You need to remember this, that we IC also called as a microelectronic circuit, microchip, or a simple chip. You must have heard this word, right? Chip. That this device has this chip, or chip is not working, so we need to replace it, right? So IC is nothing but the microelectronic circuit, also you call it microchip or a chip. An assembly of electronic components. Yes, this IC you can find other components in that, which are assembled together and fabricated as a single unit, and in which miniaturized active device you can find on it, just like transistors and the diodes, and also sometimes passive devices like capacitors and resistors and their interconnections, because of course when we are connecting all these small miniature components, then their interconnections are built upon a thin substrate. You can see in the image that a thin substrate of semiconductor material. Normally it's a silicon, right? And the resulting circuit is a small monolithic chip, which may be as small as a few square centimeters. It's very small in size, or only a few square millimeters. It's a very small in size, and the individual circuit components are generally microscopic in size. When you see the IC, sometimes you cannot see the components through the naked eye, so you need a microscope for that. So microscopic in size also. So this is a basic idea about the IC. We'll learn more about in next slide. Now let's discuss some points of ICs. So IC is basically short form is IC, we call it integrated circuit. So it's a very small in size and very small area of electronic circuits. Why small area of electronic circuits? Because it contains many hundreds, thousands, millions of components like capacitors, resistors, transistors, and diode on it, and we can diffuse all these components on the wafer semiconductor material, that is silicon. Silicon is a semiconductor material, and this wafer is made up of a silicon. So we can diffuse all these components on it to manufacture the IC, right? So this is about the basic definition or a basic idea that what is IC, and usually this IC comes in the package form. Package form means like a single IC can be represented as up to the thousands of elements which brought together into a single chip. So normally we call it a chip package, right? And also we call it a circuit system. ICs are enclosed with a solid outer cover made from the insulating material with contact or terminals called as pins. So what does it mean? As you can see in the image of the IC, you can find one black color layer. What is that? That is a solid outer cover which is made up from the insulating material, because we know that this is going to be mounted on the PCB, which is going to be used in the device under the power supply, right? So we need something which is in which has a insulating material, right? And in the end you can find the pins. This about these pins we will learn in the microprocessor topic in detail. And also the solid outer cover was designed to have a high thermal conductivity, as we just talked that because these ICs are going to be used in electronic devices and where you can find the high heat, right, because of the current power supply. So it requires the thermal conductivity, and the device is not to melt during the runtime. We have to take care about that thing because it's a metal, and when we apply the heat on the metal, it gets melted. So to prevent that from the melting, we need a thermal conductivity material. So this is some basic idea, basic points of the IC. We will learn more about in the next slide. Okay, so an IC is a, if it is asked to define the IC, how you can define? So we can say that an IC is a microscopic area of area of electronic circuits and electronic components that are diffused or implanted into the surface of semiconductor material wafer, such as a silicon, right? An IC invented by Jack Kilby in the year 1950s, and a chip is commonly termed as a IC. This is a basic definition for IC. Also, you can find the name of the founder in this definition. And these ICs are packed in a solid outer cover. Now we know this point, that these ICs are packed in a solid outer cover which can be made of an insulating material with high thermal conductivity and with contact terminals, also called pins of the circuit, coming out from the body of the IC. We can see that pins in the IC which are coming out from that body, which are actually the medium of to transfer the input output signals. So this is a basic idea of IC. Now let's see that what is the core of any IC. So the core or a main component of any IC is a transistor. So what is transistor, right? So a transistor is a semiconductor device used to amplify or switch electronic signals and electrical power. And of course it is composed of a semiconductor material, usually with at least three terminals for connection to an external circuit. That you can see in the image, that we have a transistors, four different types of transistors. This image is just to see or compare the size of the transistors, right? There is a one coin and four different transistors. We have SOT23, we can say it's a latest version or a most advanced size of the. Still we have this more smaller transistors than this. So this is transistors, and you can see three different terminals for the connection to the external circuit, because we know that we are going to incorporate these transistors in any device, right? So we need that connection for the external circuit. So these transistors may be a bipolar transistors. For field effect, we can say transistors depends upon the applications of IC. So it depends at which type of applications you are going to use, and based on that we select the transistor. And as we have already discussed, that as the technology is growing day by day, the number of transistors incorporated in an IC is also increasing, of course, because we have a smaller transistors. We can incorporate more and more transistor on a single plate. So depending upon the number of transistors in an IC or a chip, the ICs are categorized into different five types that we will see in the next slide. But here I would like to mention one point, that because when we talk about the number of transistors on an IC, it also increases the price. See, because if I have a little bit large transistors, just like this first one, this one, wait, just like this. If I incorporate this transistor on any IC, of course it might be possible that 100 or a 500 like that, right? But if I incorporate this one, of course I can incorporate more number of transistors than this one. So because more transistors are there, price will, of course it will increase the price, because I am going to utilize the IC more and more, right? So price will be also increased. uh, two other images we have, this image and this image. We discussed about the breadboard, if you remember that. Let's see, this is the breadboard with the holes in which you can uh, uh, in you can insert the different components, you can connect and you can test your logic. Because first you will draw the gate, then you will draw the truth table, then you will draw the circuit diagram, and then based on your circuit diagram you can you can implant all the components on the breadboard, and then you can attach the battery on with it, and you can test it, that is it working or not. So this is just a basic idea that how you can make a gate. See, if you notice here, here, which gate is this? Remember which gate is this? Yes, this is NOR gate. Which gate? This is NOR gate. And in this diagram, this man is designing the NOR gate circuit. So this is a basic idea of the IC and the transistors. More we will see in the next slide, that the ICs are, as we know that how ICs are categorized into different types. That types we will see in the next slide. Now let's see the categories of ICs. See, before we go for the different categories of ICs, you should know one thing, that the logic gates, we know, right? Different logic gates like a AND gate or NAND, XOR, so many. Of course, now we know flip-flops, we know microprocessors. We have not studied, but you know that microprocessors are there, counters are there. So these are the well-known examples of the ICs, and also we call it digital IC. See, ICs are analog ICs are there and digital ICs are there. We are working with the digital ICs, and these ICs are operate with binary data. Because we call it digital, or because they operate with the 0 and 1, we call it a digital ICs. And normally in digital circuits, what happens, we know that 0 indicates 0 volt and 1 indicates the plus 5 volt. Remember this thing, that when you say that in digital circuit 0 means there is a 0 volt, and means 1, there is a 1 means there is a plus 5 volt. We have already discussed this thing in the signals lecture. This is just a we are just recalling the points. And digital ICs are commonly used in many electronics project, right? And often available as added component to the top Arduino starter kits. If you read about the Arduino, it is really interesting topic, and I suggest that just read about the Arduino topics. Now we know that the main component of any IC are the transistors, right? And these transistors may be bipolar or a field effect depending on the application. That we have already studied, learned in the previous slide. As the technology is improving day by day, the number of transistors incorporated in a single IC chip is also increasing, right? And depending upon the number of transistors incorporated in a single chip, the ICs are categorized in the 5 groups. And here we have the name SSI, MSI, LSI, VLSI, and the ULSI. So SSI means small scale, medium scale, large scale, very large scale, and the ultra large scale integration. So how this categorization happen? So if there is an IC where the number of transistors in a single IC we are talking about is up to 100, means if 1 to 100, see, if 1 to 100, then that we call the small scale. If the number of transistors are in between 100 to 1000, we call it a MSI. Then 1,000 to 20,000, then 20,000 to 10 lakhs, then 10 lakhs and more than 10 lakhs. So that is the ULSI. So the categorization of IC is purely based on the number of transistors incorporated on it. And keep in mind that we are talking about a single IC chip, right? So based on the number of transistors incorporated on the single IC chip, we categorize the ICs. So we have total 5 categories of ICs: SSI, MSI, LSI, VLSI and the ULSI. Fine. So these are the different categories of ICs. Now let's discuss the advantages of ICs. So first advantage is a small in size. IC is very small in size, and the ICs are small in size, but practically it is equivalent as around 20,000 components that are incorporated in a single chip. So we call it a small, but that small size can have to around 20,000 components on single chip, right? The second point or the second advantage is a simplifies design. Yeah, simply on the end, when we talk about this simplifying the designs, on the end complex circuits are fabricated with in a single chip. Therefore designing of a complex circuit will be simplified into a single chip. We know that ICs can be found on the discrete circuit, right? And so we can say that it simplifies the design, because on the end complex circuits are fabricated with a say within a single chip, right? So designing of a complex circuit will be simplified into a single chip. Then we have the third advantage, that is high reliability. What is the meaning of high reliability? So the complex circuit are incorporated on a single chip, making it with lesser number of connections, and so soldering process will be minimized to gain high reliability, right? You got the point, right? High reliability means what? That complex circuit, we know that is a complex circuit. So complex circuits are incorporated on a single chip. We have a single chip and we are and we are making it a complex. So making it with lesser number of connections. If we have a lesser number of connections, then of course we need minimum soldering process. We need to apply the minimum soldering process, and if there is a minimum soldering process, of course the reliability is very high because we have a less connections, right? Then the fourth point is a low cost. So of course the production of ICs are done in the bulk or a mass production. If there is a production of some product in a very less numbers, then of course it has a high cost, but because it's a small in size, it is simplified design, so we can produce it in a bulk, and so it has a low cost, right? So the price of IC per unit will be reduced due to the high supply, and it will be much inexpensive rather than the creating equivalent discrete circuit of an IC. Of course, if we talk about the motherboard, so one IC on a motherboard compared to the is of course low cost compared to the motherboard, right? Then the fifth advantage is a low power. Of course, it's a low power consumption because ICs are made up of a semiconductor material wafer. We know, right, that semiconductor material wafer, and it consumes very little power or a less power. And as we know that semiconductors draw lesser power than the any other elements. Right? Whenever we talk about the power consumption, so we always go for the semiconductor material because it consumes less power. Then easy to replace component. This we have already discussed in our session, that easy to replace component. Why? Because in ICs a circuit system will be considered a single element, right? On a one circuit, if I have a PCB, I have a circuit on it, IC is a IC we consider IC is a single element. So of course replacing the entire circuit is easy rather than finding the specific component and replace it in discrete circuit, right? So also there is no need of repairing, so replacement is economical and reliable than the repairing it, so it is easy to replace component. Then the seventh advantage is increase operating speed. Yes, IC can increase the operation speed because parasitic elements such as the capacitors are omitted. We are using only transistors, which can decrease the speed. But because we are using the transistors, so it's a parasitic element. So of course, it is going to increase your operating speed. Then the next advantage is the small signal suitability. What does it mean? See, IC components are designed with very compact arrangement within the wafer. We know right that there is a silicon wafer, that is a semiconductor material on which we diffuse different components, and here we are talking about the IC, so we are talking about the transistors. So these components are held close to each other, and there is no chance to stray electrical pickups, and so we can say that there is a small signal suitability, right? So these are the main advantages of IC. There are 8 advantages, and it is very easy to remember, easy to understand actually, and this is very interesting topic, right? So now let's see the disadvantages of ICs. Right, so because it's a small in size, IC is unable to dissipate heat in required rate when current in it increased. Right, it cannot, it is not, or it cannot bear that heat. Right, and that's why ICs are often damaged due to the overcurrent flowing through them. And the second disadvantage is inductors and transformers cannot be incorporated in ICs only because of the capacitance reasons. And after the fabrication of an IC, it is not possible to modify the parameters within which an IC will operate, because we know that once it is designed, once it is fabricated, we cannot change its parameters. Like parameters means, if I am saying that this pin will work for the 0, or this pin will work for the 1, then we cannot modify that parameter. Then when a component in an IC gets damaged, the whole IC has to be replaced by new one, right? We cannot repair it. So this is one that is also a disadvantage. For higher value of the capacitance, that is greater than 30 picofarad in an IC, we should have to connect the discrete components externally. Yeah, because as we have already discussed, that because of the small in size, they cannot bear that current power supply more than certain limit, and so we can so we cannot use it in all the devices or all the circuits, and it is not possible to produce high power ICs more than the 10 watts. So these are the basic disadvantages of the IC, like unable to dissipate heat, then because of the it gets damaged, it is not replaceable, sorry, it is not repairable, and inductors and transformers cannot be used with the IC. So these are the basic disadvantages. So guys, it was all about the circuits, integrated circuits. Also we have seen about the discrete circuits. We learned about the different advantages, disadvantages of IC. So it's interesting topic, right? Because we can correlate this topic, this knowledge with our real life. So keep reading, keep learning, stay safe. Thank you.